Hi, my name's Jeff Dean, and I'm Math Dad. I'm here to help you help your kids understand math. Did you know that every number has its place? Did you know that every number takes up space? Numbers have a place and space. One of the things that students should be able to do as they're developing number sense is see how a large number can be built up by putting together smaller numbers. But if I don't understand the place of the number and I don't understand the space that numbers take up, this can be very difficult to do. It takes visualization, the ability to see a number. If I asked you to think of the number 24, go ahead, close your eyes. What do you see? Do you just see a 2 and a 4? Are you starting to make tally marks in your mind? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, I lost count. That would be hard to visualize. Or do you see something like 20 and 4? 2 10s and a 4. 5 5s minus 1. 4 6s. 6 4s. 25, which is a quarter of 100, minus 1. All of those are ways that some people might visualize what 24 actually is. Some take advantage of smaller numbers that have space, and others are really hard to visualize because we see 24 just as random symbols. One of the ways that we can help our students develop space and place is to use a number line. Suppose I have a number line and I want to locate where's the number 5 on the number line, and I was given this information. I know that 1 is right here, so where is 5? The first thing that's important is that we get the right place, that 5 is on the right side of 1 because 5 is bigger. The second thing is we want to help them develop space. We know that 5 is to the right, but how far to the right do we go? This is where using the other numbers and their space helps us to find the space for 5. This 1, this point is not what 1 is. 1 is the space. This is 1. So if I have 5, that means I have this space 1, 2, 3, 4, 5. I would put 5 right here because I used up this space 5 times. Now I can see that 5 is this big when 1 is this big. But is that the only way that I can think of it? No, there's lots of ways to get 5. If I want 5, I could think about the fact that 2 is right here because I know that 2 is made up of 2 of those spaces. But then I can say if this space is 2, then this space is 2, which means 4 is right there, and I still need 1. And I go 1, and there's 5. So in this case, I used 1 plus 1 plus 1 plus 1 plus 1 equals 5. And in the second case, I used 2 plus 2 plus 1 equals 5. I'm starting to see that 5 can be built using smaller numbers. Once students get the hang of placing a number when they know where 1 is, then you can start to give them other numbers like 2 or 3 or even larger. If I want to know where 5 is and I know 2 is right here, if this is 2, this is 4. But where's 5? Well, I know 5 is one more. I know it's in this place. But what is the space? We use what we know about 2. We know 1 is here. So I have my space of 1, which I can add right here. So I have 2 plus 1 is equal to 5. Well, what if I gave you a 3 and you wanted to know where 5 is? There might be a couple ways that students could build this. If this is 3, here's 3 more, but now I'm at 6. I've gone too far. I need to take 1 away. In order to take 1 away, I need to know the space of 1. If this is the space of 3, this here is the space of 1. So I go that much space, and there's 5. So here I had 3 plus 3 minus 1 equals 5. When students start playing around with different pieces on the number line, they start to see how a larger number is built from smaller numbers. This gives them an idea of the space or the size of a number and allows them to visualize what they're dealing with. I could have also said, if this is 3, I know the place for 5 is over here. And if this is 1 and this is 1, that means this space is 2. So I take that space and I move it here and I get 5. And there's my 3 plus 2 equals 5. Not only am I developing an understanding of the relationship numbers have, but I'm starting to help students see that 5 can be built many different ways. And I'm developing a flexible thinker. Now let's go back to the number we were visualizing, 24. If I want to know where 24 is, and I know 5 is here on the number line, what can I do? Well, I can say 5, and 5 more makes 10. This is 10, and 10 more makes 20. This is 20. I could do a couple of things here. I could either just start going 21, 22, 23, 24, but we want to encourage our kids to use bigger chunks. So I can take 5 again and place it here, but that takes me to 25. So now what do I have to do? I got to figure out how big 1 is so that I can remove that piece. Then come back here to 5 and say 1, 2, 3, 4, 5. I know how big 1 is. I can remove that much, which places 24 right here. So what did I do? I said 5 plus 5 plus 10 plus 5 minus 1. Large numbers are made up of smaller numbers. They all have space and they all have a place. What about if I know 2 is here? Well, I have 2. That would mean that this is 4. This is 4, which would mean this right here would be 8. And now that I have 8, I can go 8, 16, and 8 more, 24. So here I went 2 plus 2 plus 4 plus 8 plus 8. And I got 24. Now, if you're thinking, this isn't a very efficient way of making 24, you might be right, but we're not looking for an efficient way of building 24. We're looking at building number sense. We want our students to be flexible thinkers. We want them to see that there are lots of ways to build numbers, and I can build them in a way that's most convenient for the information that I'm given. And once they see that there's a best way in relationship to the information that they're given, they've started to make a lot of sense out of numbers. My name's Jeff